In this video, I'm going to introduce random variables and probability distributions. So random variable, usually we use capital letters to note random variables. So X is a really common random variable, capital X. This is a variable whose value is determined by chance. Okay, so there's a certain probability that's associated with this variable. There's two types of random variables that we'll go through in this class, discrete and continuous. Okay, we're going to focus on discrete here in the beginning, and so during this chapter we're going to be focusing on discrete random variables, and then in the next chapter we'll focus on continuous random variables. So discrete random variables are random variables that are finite or countable. So this would be, for example, counting, the number of cars in a parking lot, right? That's random day to day, right? That's random, and it's a discrete count. There's 1 car, 2 car, 3 cars, however many cars are in the parking lot. A continuous random variable has infinitely many values and can be associated with measures on a continuous scale. So for example, the height of trees in a forest, right? We could measure those heights, and those heights would be continuous on the continuous scale. Okay, so what's a probability distribution? Well, probability distribution is a function that gives the probability for each value of the random variable. Right? You remember in math class, you used to have like f of x, right? And this was, the function value for the variable x. So probability distributions, this is very similar, except now instead of f of x, just for discrete random variables, often our notation is p or pr of x. All right. So the probability of observing this random variable. So this would be the probability. So instead of it being a function value, now it's a probability value. All right. So that's what a probability distribution is. Okay. We'll do some examples of actually finding probability distributions in the next video. But let's go ahead and talk a little bit more about probability distributions, the requirements for probability distributions. First requirement is that if you sum over all the different possible x values, all the different possible values that the random variable can take, it should sum up to 1, right? Total probability equals 1. That makes sense. Also, for every value of x, the function, the probability distribution function, should be between 0 and 1, which also makes sense because this is a probability. Probabilities need to be between 0 and 1. All right. Let's do an example where we need to determine whether or not this is the probability distribution represented using a table. Okay. So this is a probability distribution using a table. And we need to find which ones are probability distributions and which ones are not. Okay. So first, this one we need to check the two required criteria. Is the sum of all the probabilities equal to 1? Yes, right? If you were to add up all these probabilities, 1, 6 plus 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 1, 6, you sum them up equals 1. Next criteria, are all of these probability values between 0 and 1? Yes, they are. Okay, so this is a valid probability distribution function. As a matter of fact, this is the probability distribution function for rolling a 6-sided die. Is that right? Because you have possible outcomes of the random variable would be the outcome of the die. So it could be 1, 2, 3, 4, 5, or 6. And the probability is all 1/6 for any of the sides. Okay. All right. Next, we have. Let's go ahead and check our criteria. If we were to add up 1/6 plus 1/3 plus 0 plus 0 plus 0 plus 1/2, it equals 1. Good. And then if we were to look, are all these probabilities between 0 and 1? Yes, they are. So this is a valid probability distribution function. All right. This might be a weighted die. that actually the die appears to not even have the sides 3, 4, and 5 because those probabilities are 0. So the die appears to only have the sides 1, 2, and 6. So it's a very strange die, a very strange the probability distribution function for perhaps like a very strange dice. All right, let's do one more. So say we have, probability is 1/3, 1/3, 1/2, 1/6, and 1/2. So if we add up those probabilities, it's more than 1. So this is not a valid probability distribution function. So this is not a probability distribution function for anything. Okay. Let's see this last one. If we were to add up all of these, negative 1/6, 1/6, 1/3, 1/6, 1/6, 1/6, it adds up to 1, but this negative 1/6 is not a valid probability, right? The probability needs to be between 0 and 1. So this is also not a valid probability distribution function.